ladies, gents, and everyones. It is Thursday, June 10th, and we're here to talk about this week's space and astronomy news. Jeff Bezos announced on Monday that both he and his brother will be on board Blue Origin's first crewed mission launch to space, which is scheduled for July 20th. Now, this is also the launch that's going to include a seat that is currently being auctioned off, and the high bid stands as of this morning at $4 million. This auction will culminate in the live auction event on Saturday, at which point I guess we will find out what the final price is, as well as who the third person on this new Shepard crewed mission is going to be. The Senate passed a bipartisan act on Tuesday called the U.S. Innovation and Competitiveness Act, and this act included NASA's authorization bill. Now, in case you're not familiar with how government funding works, an authorization bill does not actually give any money to anyone. That requires an appropriations bill, but an authorization bill is kind of, the first step along the way to eventually getting money. Now, a key space policy implication clause of this act is that NASA is going to be required to award two entities contracts for the Artemis Lunar Human Landing System, or HLS. Now, NASA wanted to award two contracts for this for redundancy's sake at this point in the process. However, they didn't have the funding to do so, and so they only awarded one contract, and that was to SpaceX for its Starship HLS back in April of this year. Now, that award was protested by the losing bidders, Blue Origin and Dynetics, and is currently going through the Government Accountability Office for that protest. So that will have to come into play, I guess, with this new requirement for NASA to award it to two different entities and hopefully get the funding to actually do so. NASA Administrator Bill Nelson issued a statement in support of the act on Tuesday after its Senate passage. Now this bill is going to have to go to the House to be passed there before it goes to President Biden for signature. So we've covered in the past China's new Tiangong space station and the missions that they have launched in support of getting that up and running, including the Tianhe core module, which was launched in April, as well as a supply mission that launched last month. Well, now the next step is to send astronauts to this new space station. So China is planning to send 3 CNSA astronauts to live on board the space station for 3 months, which will set a record for China's longest mission in space, which currently stands at 33 days from the Shenzhou-12 mission back in 2016. While China, as ever, has not released many details about this launch, it does look that it is scheduled to be next week, and it appears to be on schedule, as the Long March rocket and the Shenzhou-12 spaceship were moved to the launch pad yesterday. The ESA announced today the selection of EnVision as the 5th medium-class mission as part of its Cosmic Vision plan. EnVision is a Venus orbiter mission, and this comes only a week after NASA just announced the selection of 2 Venus missions for its Discovery program. So Venus is the place to be, and these 3 missions will be complementary to one another and really help us further our understanding of Venus, which is just super exciting for planetary scientists and astronomers and scientists everywhere. EnVision will carry 6 scientific instruments on board, and they will really be focused on observing the tesserae on Venus, which are these surface features similar to continents on Earth that we don't even know what they're made of or what the composition of them are. So this is really cool. And the mission is expected to launch in the early 2030s. I just said early 2030s and that sounded so far away, and then I realized that's less than 10 years from now, so having a bit of an existential crisis now. The astronomical phenomena known as fast radio bursts are exactly what the name suggests. They are short, so millisecond time length pulses that emit in the radio wavelength. These pulses contain quite a lot of energy when they are emitted. However, that energy dissipates a lot by the time the signal reaches us, and actually the time of the signal kind of smears out as well. And so while they're milliseconds at the source, they do tend to last a couple seconds by the time we observe them. Now, the very first FRB was detected in 2007 from archival 2001 data, so we haven't really known about these for a very long time. The first FRB, in fact, I think the only FRB that's known to be inside our own galaxy, was not discovered until 2020 with a relatively new telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment. Now, CHIME wasn't even originally planned to look for FRBs, but it was kind of added into the scientific mission, and I think there was some skeptics of that, but probably not anymore, because CHIME just announced this week 535 FRBs. This means that the number of known FRBs quadrupled overnight. And this is just from their first year of observation, so that was 2018 to 2019, so I'm sure we're going to get much more from CHIME. But these data are incredibly important because astronomers don't actually know what the source of FRBs are. Now, one early result that seems to be coming from this CHIME data, and again, this was just released, so there is still going to be quite a lot of science coming from this, but it does appear that there are at least two distinct classes of FRBs that probably have different origins. So repeater FRBs are regular pulses that come from the same source, as opposed to these kind of single FRBs or one-off FRBs that we only see once. So if that was the only difference between these two FRBs, you might think, okay, these one-off FRBs, maybe they are repeating and we just haven't seen the repetition yet. However, it does seem now that there are actually some more differences between these two types. For example, the one-off FRBs seem to be a little bit shorter in time, the pulse length, and they kind of have a wider range of wavelengths, whereas these repeater FRBs are a little bit longer in time and have a much narrower range of wavelength. So all of this new observational data is going to be a gift and a challenge for theorists, and hopefully we can learn a lot more about FRBs from this. Well, that's all I have for you this week. Thank you so much for watching. I hope you will join us again next week, and I just want one more time to plug the premiere of the Cosmos show, which is happening next Tuesday. I'm super excited, so please check that out and come and hang out with us. So, all right. Thank you so much. Have a good one. Bye.